Hello Legacy Sabers, Marsh here. So today we're going to review how to solve a system with three variables. This is review from what we did in class, but this is in case you missed it or in case you need to review the concept. So what does a three variables look like? Well, it's a 3D graph technically if you would graph it. So the solution is now a point in space and an order triple, an x, a y, and a z. So now we have also depth in our equation. So now, here are the steps we're going to take to solve a system with three variables. We're first going to pick two equations from the three and eliminate a variable. Then we're going to pick two different equations, eliminate the same variable. Now, those two equations that we now made, we're going to solve that system and then substitute back in, write our answer, and of course check. Now, let's start in and make sure we know what we're doing. So I have this system, negative x plus y plus 2z equals 2, 2x plus y minus z equals negative 4, and x plus 2y plus 3z equals 2. So what I'm first going to do is pick two of these equations and eliminate one of the variables. So the very first thing I notice, there's an easy one right here. This is negative x and that's a positive x. I'm going to eliminate that first. I'm going to eliminate x because they already at this current time will eliminate one another. So those are the two equations I'm going to pick. Remember guys, my z's, I'm going to cross them over so that my 2's and my z's don't get confused. So negative x plus x, that is gone. Y plus 2y, that is 3y. 2z plus 3z is 5z's, and 2 plus 2 is 4. So I have 3y plus 5z equals 4. I have one of my 2 by 2 equations, an equation with two variables. Now, let's pick two different equations and eliminate the same variable. So basically eliminate x again. But I cannot pick the first and the third equation. Again, I need to pick two different ones. So I'm going to pick the first and the second because one has a negative, one has a positive for my x's. So I will have negative x plus y plus 2z equals 2 and 2x plus y minus z equals negative 4. So I need to get my x's to cancel again. So let's multiply. I need them to be both the same number, right? Both a 2, one needs to be negative, one needs to be positive. I have the negative and I have the positive taken care of. So I need this to be multiplied by 2 for everything up here. Because then I'll get a negative 2x, right? So I'll get negative 2x plus 2y plus 4z equals 4. Okay, 2x minus 2x, gone. Y plus 2y, that is a 3y. Negative z plus 4z, that is a positive 3z. And negative 4 plus 4 is 0. So now I have another equation with only two variables. So now what I'm going to do is take the two equations that we solved for, that we got once we eliminated, and I'm going to solve this system like we would have done back in Algebra 1. But notice now I have a y and a z for this equation. Let's solve like we normally would. So I'm going to cancel out my y's, I think, because they both have the same number. But right now I can't cancel them because I need one of them to be a negative when I add, right? So let's multiply everything on the top equation by negative 1. I could do it to the bottom as well. I just like to do it to the top because then I can just rewrite the top equation on the bottom. Whoops. There we go. 3y minus 3y, that is gone. 3z minus 5z, that is a negative 2z. And 0 minus 4, that is negative 4. So solving for z here, we get z equals a negative 4 divided by a negative 2, or just good old 2. Now, how did we get the second variable's value when we were solving a system? Well, we just plugged in, right? So let's take this and plug it into one of the two equations that we have. So I have 3y plus 5 times 2 equals 4, or 3y plus 10 equals 4. So let's start solving here. Subtract the 10, get negative 6, divide by 3, y equals negative 2. Now, I have two of my values. I have z equals 2 and y equals negative 2. So now, what I'm going to do is substitute two of those variables that I just got into one of the original equations, the ones that we started the problem off with, to get the value of the last variable. So, I'm going to plug into the top equation, not as much math involved. So I have negative x, right, because we don't have the x value, plus my y value, which is a negative 2, plus 2 times my z value, which is 2, and that all equals 2. So negative x minus 2 plus 4 equals 2, or negative x plus 2, right? If we combine some like terms, subtract 2, get negative x equals 0, or x equals 0. So now I have the values of the three variables. So I'm going to write them as an ordered triple. So it's going to look like just like an ordered pair, but you're going to have an x, y, z inside. So it's going to be x first, which is 0, y, which is negative 2, and z, which is 2. So my answer to my system is 0, negative 2, and 2. Now, you're not done. You do now need to check your solution value. So, let's plug in the point, or the ordered pair, ordered triple, 0, negative 2, and 2 into each one of the equations. So I got negative 0 plus a negative 2 plus 2 times 2 equals 2. That's going to cancel off. I'm going to be left with negative 2 plus 4 equals 2, which is 2 equals 2, right? That works. Let's check the second equation here. First, second. So I got 2 times 0 plus a negative 2 minus a 2 equals negative 4. This is 0, so we're going to cancel that out. I get negative 2 minus 2 equals negative 4, or, of course, negative 4 equals negative 4. Good on number 2. Let's check number 3. 0 plus 2 times my y value, negative 2, plus 3 times my z value of 2 equals 2. 0's gone. 2 times negative 2 is negative 4. 3 times 2 is 6. And I get 2 equals 2, which checks out. So the point 0, negative 2, and 2 is a solution to my 3x3 system. And that's the end of this video. See you later, Sabers.